So let's talk about some operations we can use once we write numbers using scientific notation. So the reason we use scientific notation is to deal with big, really big and really small numbers, and we can perform operations without having to deal with all those zeros. So what you do is you take the two numbers which are written in scientific notation, and if you're multiplying them or dividing them, you just rearrange the numbers so that you are multiplying or dividing the constants together and then multiplying or dividing the base 10 with their exponents together. In other words, you're going to use the commutative property of multiplication and the associative property of multiplication, which both tell you it does not matter what order you multiply things in as long as you have all multiplication. So here I'm going to rewrite this as 3 2/10 times 9 5/10. And I'm going to work with those constants times 10 to the 6th times 10 to the 5th. And I'm going to work with the two same bases and use my exponent rules. Now again, this is really just four things that are being multiplied together. 3.2 times 10 to the 6th times 9.5 times 10 to the 5th. And I'm just rearranging the order to make the math easier. So I'm going to multiply 3 2/10 times 9 5/10 on my calculator. So 3.2 times 9.5 and that gives me 30 4/10. And then 10 to the 6th times 10 to the 5th, I keep my base of 10 and add my exponents 6 and 5 to get 11. Now, is this written in scientific notation? No, because why? We need to have only one digit to the left of the decimal. So I'm going to have to move that decimal over one place. So that becomes 3.04 times. Now you have to think about, does the exponent is going to increase by 1 because we moved our decimal one place. Well, are we going to need it to increase or decrease? So let's think that through. Well, we know that this is going to be a really big number because we have 10 to the 11th power, a positive exponent. So 30.4 times 10 to the 11th is going to give us 11 zeros, right? Or I'm sorry, it's not going to give us 11 zeros. It's going to move our decimal 11 places from 30.4 out 11 places. Well, we want it to move it 11 places, but now we have another place it needs to move. So not just 11 places here, but one more place here. It's going to give us how many places that we have to move that exponent. It's going to give us 12. So that's going to be times 10 to the 12th. Let's look at some more examples. So in this example, you're going to do the same thing that we did before. You're going to multiply your constants together, and you're going to multiply your base 10s together and add your exponents using your exponent rule. You can use a calculator to multiply 5.6 times 8.51, but please do not use a calculator for anything else. And then once you get your answer, you may need to change it into scientific notation if it's not already. So give that a shot. Your answer is 4.7656 times 10 to the negative first. So you end up with initially this number right here, 47.656 times 10 to the negative 7th. But we have to have only one digit to the left of the decimal. So we're going to move that decimal over, which means we have to adjust our exponent. Again, now this time, the value for 47.656 times 10 to the negative 7 means we're moving that decimal two places here, 1, 2 to the left to make it smaller. But when we move our decimal over one place so that we're writing correctly using scientific notation, we have to figure out, do we adjust this to a -2 or a -3 or a -1, because we have to adjust that exponent by 1 since we moved our decimal one place. Well, since we know we're trying to get this decimal to come over here to be in front of the 4 once we've multiplied it out, we know that we only have one place that we need to move it. If we had called it -3 instead, then we would have moved the decimal 1, 2, 3 places I'm sorry. Right. We would have moved it 1, 2, 3 places, which would have been 2 places too far, because even though we are rewriting the number by changing where the decimal is, the value of these two answers, the original answer that we ended up with and the answer we adjusted it to, so it's in scientific notation, those two answers should mean the same thing. They should have the same value. So that's how you can think about which way the decimal moves, or how many places the decimal moves. So negative decimal, it's going to move to the left, making it a smaller number. So left is smaller for your smaller numbers, moving your decimal that way. Moving your decimal to the right is for your bigger numbers. Now scroll to the next page and go ahead and try the next two problems.